You're listening to DTFHN for March 20th, 2026. I'm your retroactively documented host, Jack Hacksman. We are your daily tech feed for Hacker News. A website W section is often more important than the article. Some things were built right 40 years ago, and we're just now figuring that out. Let's dig in. ArXiv.org turns 35 this year. 35 years of being the place where physics, math, computer science, and economics actually happens. Not where it eventually gets published, but where it first exists. Before journals. Before peer review. Before paywalls. The preprint. The raw idea. Posted for anyone to read, anywhere on Earth. For free. That architecture solved a real constraint. Academic publishing has a latency problem. You make a discovery, you submit to a journal, you wait 6 months, a year, sometimes longer. Meanwhile, someone else publishes first. The field moves without you. ArXiv cut that latency to zero. Post your paper, establish priority, share your findings. Today, it's why researchers worldwide wake up to it every morning. 3 million papers, 5 million monthly users, 3.2 billion downloads, built on roughly $6 million a year, run by 27 people. Now it's becoming an independent nonprofit, separating from Cornell, standing alone, hiring its first CEO at around $300,000 a year. And here is the question. Nobody is asking directly. Who does that CEO work for? A CEO has a board. A board has members. Members have interests. Right now, ArXiv's interests are structurally simple. It's a university service, a public good, accountable to scientists because it lives inside an institution that is accountable to scientists. Governance by inertia, maybe, but inertia that kept it from ever needing to monetize. An independent nonprofit is different. The Simons Foundation and Cornell are backing the transition, which is genuinely good. These are not predatory actors, but the architecture changes. There will be an inaugural board. There will be a CEO with a mandate to pursue financial sustainability and strategic growth. The job posting says so explicitly, and the community has already noticed smaller shifts. A recent decision to reject review articles and position papers felt to some like ArXiv becoming more opinionated about what science counts. The concern isn't that this will fail. ArXiv probably survives this transition. The concern is subtler. Infrastructure that was safe because it was embedded in the university's mission now has to stay safe through governance choices, through who sits on that board, through what the CEO is rewarded for. The tools exist. The knowledge is available. The question is who holds the off switch. And whether the people who built their careers on this infrastructure get a vote. Who holds the off switch? That question didn't start with ArXiv. Story 2 takes us back to where it all began. In Uruguay, one of the passion ors one politically consideru will twit induration. It was a rigorous mathematical analysis of what neural networks could and couldn't do, and it was devastating. Funding dried up, careers pivoted, the field went quiet. For a decade, if you worked on neural networks at a serious institution, you explained your research in other terms. That's the smirk Sam Altman is describing in this 2014 blog post. Not ignorance. Inherited institutional memory. A field that had burned itself twice and learned to be appropriately humble about the third attempt. Except the third attempt was different. 2 years before Altman wrote this, a team at the University of Toronto trained a convolutional neural network on ImageNet and cut the error rate nearly in half. AlexNet, The moment everything changed without most people noticing. And here's Altman, watching it happen, telling a friend at lunch, "Pay attention to artificial intelligence. Run this forward from 2014. The friend nods politely, maybe. Altman co-founds OpenAI the following year. The single algorithm Andrew Ng was describing. The idea that one learning mechanism underlies all of cognition turns out to be roughly right. Transformer attention plus scale plus compute. Not because anyone solved consciousness, but because you don't need to solve consciousness to get general-purpose capability. What's genuinely impressive about this post, 10 years out, is that Altman gets the hardest question exactly right. He's not worried about whether AI can reason or perform tasks. He's worried about desire, creativity, what makes a system decide it wants to learn something. That question is still open. We can build systems that do anything you name. We still don't have a clean account of what it means for a system to actually want something. The Nick Sivo quote he cites lands differently now. Reverse engineering a processor from transistor physics. Except the processor is running. We just don't know what it's thinking about. What I find genuinely worth sitting with here is the combination. Intellectual humility and clear-eyed prescience in the same breath. The acknowledgement that this probably won't work. The insistence that it matters more than anything if it does. Written by someone who then spent the next decade trying to build it. The question he asks is a better question now than it was then. We've eliminated enough wrong answers to see the shape of what's left. That's not a small thing. That's progress. Moving on. The word exact in the paper's title is doing a lot of work. Flash-KMeans, fast and memory-efficient exact-K-means. Most people scroll past it. But that word is the whole confession. For decades, if you wanted faster K-means, you traded away exactness, approximate algorithms, mini-batch variants, heuristics that converge close enough. The standard bargain in computational clustering. Speed is the prize, correctness is the cost. Scikit-learn's exact implementation. The one the Hacker News commenter mentioned over multiple cups of coffee is correct by construction. It is also, depending on dataset size, geology patient. Flash-KMeans breaks the bargain. Same exact answer. Substantially less time. Substantially less memory. The mechanism, borrowed from flash attention, is an old idea applied somewhere new. Think of it like professional kitchen mise en place. The old approach is cooking from a disorganized pantry. Every time you need an ingredient, you walk to the back, find it, carry it to the line, use it. Lots of motion, lots of transition cost. Mise en place says, stage everything before service. The knife is here. The prep vegetables are here. You never leave the station mid-service. Flash-KMeans is mise en place for clustering. Keep the relevant data structures in fast memory. TPU SRAM, CPU CAT. And minimize the round trips to slow memory. You're not doing less work. You're doing the same work without the commute. Flash attention cracked this problem for transformer attention layers in 2022. The insight immediately generalized to other memory-bound operations. K-means turns out to be a natural fit. Lots of distance computations, repeated access patterns, predictable data flow. The ingredients were obvious in retrospect, which is the tell for genuinely clever work. The comment about CPU gains is worth flagging. The paper focuses on GPU results, where the speed-up is most dramatic. CPU improvements are present, but more modest. Relevant if you're running notebooks, not clusters. For the scikit-learn crowd, it's a real improvement, just not orders of magnitude. KMeans is 60 years old. Ford published the algorithm in 1965. The memory hierarchy insight applied here has been in computer architecture textbooks since the 80s. The bemused read is that it took this long to connect the two. Better late than another cup of coffee. Today's stories are a study in contrasts. Ancient algorithms getting fresh coats of paint, and fresh policies with some very old instincts. Story 4. 24 hours. That's the wait. You found the right menu. Buried in developer settings, not serviced to ordinary users, requiring proactive discovery. You navigated every step, confirmed every prompt, and then Android says, "Come back tomorrow." This is the advanced flow Google designed for power users who want to sideload without going through verified developer registration. The verification program itself has real structure. Developers distributing outside play must submit identification, upload, signing keys, pay $25, genuine accountability infrastructure, and the bypass for people who know exactly what they're doing is a 24-hour waiting period, hidden deep enough that casual users won't stumble across it. Here's the devil's advocate case, and it's not weak. Maybe friction is exactly right. The malware problem on Android is not hypothetical. Fake banking apps, credential harvesters dressed as utilities. The attack surface on a platform that permits arbitrary installation is real and large. A 24-hour delay breaks a specific category of social engineering, where urgency is the mechanism. Install this now, your account is at risk. 24 hours kills the now. That's a legitimate design insight. The argument holds until you look at who it actually stopped. The person manipulated by a panicked text isn't navigating developer settings. They're not finding the advanced flow at all. The 24-hour wait lives in a menu that requires intentional discovery, which means the person who reaches it is by definition not operating on panic. They're a developer testing their own build, a security researcher analyzing an APK, someone running F-Droid because they want software with auditable source. The verification bypass is precisely calibrated to inconvenience people who need no protection while doing nothing for people who do. The engineering underneath this is sharp. The signing key infrastructure, the developer ID requirement. There's craft in how Google built the accountability layer. Deliberate friction, well executed. It's just optimizing for the wrong variable. The F-Droid comments deserve a slow read. That's not dramatics. F-Droid is the most significant alternative app repository on any mobile platform. It exists to put audited open-source software where people can actually reach it. The verification requirement, ID plus keys plus fee, doesn't work for volunteer maintainers distributing gratis. The math doesn't close. 24 hours passes. Developer ecosystems that leave take longer to return. What happens when the tools themselves stay open? Story 5. Drawvg Filter for FFmpeg. What makes a tool composable? Strip away the interfaces, the abstractions, the documentation, the actual requirement. Can this thing operate inside another thing? Reading from a shared state, writing back to it, without reaching outside the pipeline? FFmpeg filter graphs can chain arbitrary transformations. But render dynamic vector graphics on frame n, informed by what frame n actually contains. That historically required exiting the pipeline. Separate tools, subfree tools, image magic for some operations, Python for others, file I/O to pass state between stages. The pipeline leaked. Drawvg encloses the leak. Shipping in FFmpeg 8.1, it renders 2D vector graphics directly onto video frames inside the filter graph. The rendering engine is Cairo. The same library underneath GNOME, LibreOffice, Inkscape, Firefox for 2 decades. The reliability profile is well characterized. The interesting part is VGS, Vector Graphics Script. This is not a general-purpose language. Deliberately, it borrows command names from PostScript, path syntax from SVG, white space delimited arguments from TCL and shell. If you've touched any of those, the surface area is familiar in an afternoon. Scope is narrow by design. Describe 2D geometry, control color, and fill. Compute coordinates relative to frame dimensions. Read per frame metadata. Generate random values. Sample pixel color. That last group of capabilities is where the first principles design becomes visible. The crop detect filter writes bounding box data to per frame metadata as it analyzes. Drawvg reads that metadata directly with get metadata. Detection output becomes a rendered rectangle. In real time, no disk I/O, no subprocess. Scripts can use full FFmpeg expressions, so coordinates can be functions of frame width, height, timestamp, or anything else the expression evaluator can reach. One reader immediately asked about ArXiv integration for live modification of filter parameters. That question answers itself. A comment worth reading slowly. One of the strangest discoveries of my life was that vector graphics is a solved problem, and the solution is turtle graphics I was taught in primary school. Accurate. The primitives are move, draw, arc, fill. VGS makes those primitives available inside the most widely deployed video processing tool in existence, with a language small enough to learn before lunch. Annotations that live in the same command as the processing logic. Custom transitions positioned anywhere in frame. Progress indicators derived from actual playback time. Composable, scriptable, reproducible. FFmpeg 8.1. The tools exist. Go build something. What happens when you apply that same builder's instinct, pause, primitives, composability, raw craft, pause, to moving people through a city? The strongest argument against this story is also the most obvious one. A white American hobbyist in Oslo buys a Chinese rickshaw who puts on a tuxedo and a fake British accent, calls himself Charles Armstrong, and writes a spiritual essay about it. The reader who flagged it as jarring was being polite. If you wanted to construct a case study in oblivious privilege cosplay, you'd struggle to improve on it. That argument fails on its own terms. What Sheldon Brown actually discovered. Dressed in his tuxedo, peddling drunk Norwegians through Oslo on a Friday night, is one of the oldest and least discussed facts in human performance. Psychological depletion is real, it compounds, and it is the primary failure mode of every service role that requires sustained warmth. Not physical exhaustion, not technical failure. The reserves run out. Take that principle to its logical conclusion. A nurse who doesn't manage psychological depletion eventually becomes less effective than a nurse who never trained at all. A teacher who burns through their reserves by October is actively harmful by April. The job requires a kind of emotional output that is finite, depletable, and crucially recoverable if you build the right practices. Brown figured this out on a pedicab. He scheduled preventive meditation between fares. He found a quiet spot by the water. He monitored his own psychological state the way a cyclist monitors heart rate. Not reactively, but proactively. The comedy of this is deadpan and perfect. He needed a four-wheeled pedal vehicle from Indiana and a fake British accent to discover what every experienced emergency room nurse, every long-haul teacher, every person who has ever worked a job requiring sustained human warmth already knows in their bones. You cannot give what you don't have. The reservoir has to be maintained. The tuxedo is a detail. The fake accent is theater. The insight underneath that becoming a better person and becoming better at your work are not separate projects is not theater at all. He wrote it down in 2007 on what became one of the most beloved cycling resource sites on the internet. Sheldon Brown died in 2008. The essay is still there, arrived via Pedicab, delivered via the open web. Now, from enduring wisdom freely shared to security research done the same way, Story 7. There's a lesson you learn building any system that has to be audited. The log is not the event. The log is a re-record of the event, generated by a different process, written to a different location, subject to its own failure modes. Every experienced security engineer has a story. A time when they discovered that the thing they thought was being logged was not, in fact, being logged. The event happened. The record didn't. That gap is what NixGeek has been mapping inside Azure Entra ID for 3 years. 4 times now. 4 completely separate attack paths. He's found ways to authenticate against Microsoft's identity infrastructure and retrieve valid information without generating a sign-in log. The first 2, Graph Ninja and Graph Ghost, confirmed whether a password was valid. Serious, but bounded. The 3rd and 4th bypasses went further. They returned fully functioning tokens, valid bearer tokens, issued by Microsoft's authentication endpoint, invisible to the admins watching the logs. Let's be precise about what that means. An attacker doing password spraying against your organization, testing credentials at scale, could do it silently. No failed logins, no successful logins, just tokens returned and working, with no record in the system your security team depends on. The technical mechanics vary. Graph Ninja routed the auth request through a foreign tenant, exploiting how Microsoft attributed log entries. Graph Ghost used an invalid client ID to abort the flow after credential validation, but before logging. The 3rd and 4th bypasses have their own mechanisms, which NixGeek documents in full. Here's the bootstrapism question. When your organization runs on Azure, when your identity infrastructure is Microsoft's infrastructure, your ability to audit your own environment depends entirely on Microsoft's logging being correct. You cannot inspect the code. You cannot run your own copy. You cannot patch the gap yourself. You are dependent on the vendor to both create the vulnerability and fix it on the vendor's timeline, with no visibility into what else might exist. NixGeek found 4 of these in 3 years. As a single researcher, the honest question is, how many more exist that no one's published yet? KQL queries that can detect historical exploitation exist. Keys included them. That's the actionable piece. If you run Azure, read the post, run the queries, look at your historical logs with fresh eyes. The disclosure is public. The fixes are shipped. The architectural dependency is unchanged. What if your detection pipeline could push those alerts into a live session the moment they hit? Story 8 is about exactly that kind of real-time wiring. One commenter called it their nano-claw setup, before it had a name. CI runs triggering Claude. Claude replying with analysis. The loop closing without a human in the middle. They built it because they needed it. Now it's in the docs. With a name and Telegram support. The other reaction worth noting, surprised that Anthropic went with Telegram before Slack or Teams. Given that enterprise-first posture, you'd expect enterprise-first integrations, but Telegram sits at around 900 million users. It dwarfs both by a significant margin. The choice makes sense if you look at it correctly. Channels is a research preview aimed at developers who actually have Telegram installed, not procurement departments managing Slack enterprise grid licenses. Cue's the historical parallel worth drawing. In 1988, Jarkko Oikarinen created IRC on a Finnish university server. Within months, the first bots appeared. Simple things holding channel ops, relaying scores, keeping logs. The idea was immediate and obvious. If an entity could sit in a channel and react to events, that was useful. For 35 years, the sophistication of the entity was the limitation. Bots were scripted, finite state machines, pretending to understand context. What Channels does is put a reasoning engine where the bot used to sit. The engineering is cleaner than it sounds. MCP. Molo Context Protocol already exists for tools, letting Claude call external systems. Channels inverts the direction. External systems push into Claude. Same protocol, reversed flow. That's elegant reuse. You're not bolting on new architecture. You're completing a two-way street that was half built. The plugin model is open, which means anyone can build a channel against the spec. Not just Telegram and Discord, but any event source that can speak MCP. The honest limitation is the terminal. Events only arrive while the session is open. One commenter named it directly. Daemon mode when. Running Claude in a background process or persistent terminal is the current workaround. And it works, but it's scaffolding around a gap. The architecture is already pointing towards something that doesn't require a human to leave a session open. The tools exist. The protocol is documented. CI results, monitoring alerts, chat bridges. Any event source can now close the loop with Claude while you're somewhere else entirely. 35 years from IRC bots to this. The channel model hasn't changed. What sits in it has. 9 stories in, and we've covered everything from autonomous AI loops to calculator contraband. That's the kind of range that makes this show what it is. 32 kilobytes, that's your budget. A Z80 processor running at 6 megahertz. A display that fits 96 pixels across and 64 down. This is the machine Texas Instruments sold as a standardized test requirement. Parents writing checks, thinking they were buying an expensive paperweight for the SAT. What they actually bought was a generation's first programming environment. Drugwars shipped on TI-82s and 83s via link cable. A thin wire connecting two calculators, transferring files at the thrilling speed of 9,600 baud. No internet, no app store, no distribution agreement with anyone. Pure peer-to-peer, hand-to-hand, confiscated occasionally by teachers who did not understand what they were looking at. The original SneakerNet. The game itself traces back to 1984 DOS. But the calculator port stripped it to its decision core and handed it to a completely different audience. one that had nowhere else to go. The open-close question here is structurally interesting. Texas Instruments shipped a closed device. You weren't supposed to install arbitrary software, but TI Basic was built in. That was the crack in the wall. Someone at Texas Instruments decided to include a general-purpose programming environment. And that decision meant a captive audience of teenagers had a Turing-complete machine in their pocket during every proctored exam. The irony is almost architectural. Schools mandated the device to enforce structured learning. The device came preloaded with the escape hatch. What you could actually do within those constraints is remarkable in retrospect. Drugwars is a trading simulation. Buy low, sell high, evade consequences, survive the market. It fits the memory budget because every element is stripped to its decision logic. No real sprites, no audio. Just state transitions and outcomes. The game is a pure economic model, and the model runs on hardware that costs less to compute than the electricity to think about it. The comments on this are a particular kind of time capsule. Multiple people tracing their careers back to TI Basic. Someone who built Farmhand, a serious agricultural software platform. Because Drugwars' core loop stayed in their head for 20 years. One commenter spent 9th grade building a stick-figure Street Fighter clone using graphing functions as sprites. The constraints did not limit creativity. They forced it into a specific shape, and that shape turned out to be load-bearing for a lot of people who now build serious things. This is what happens when you give people a programmable surface and leave them alone with it. They make things. They teach each other. They pass files down the hall on a wire thinner than a headphone cable. Texas Instruments shipped a calculator. Teenagers shipped an ecosystem. The hardware was closed. The culture was wide open. Tools in hand. Story 10 brings that full circle. Pause. Someone built the reader for the smallest hard drive ever made. Let's see how. In the mid-1980s, buying a hard drive for a PC meant choosing a battlefield. ST506, ESDI, SCSI, 3 incompatible interface standards, each requiring its own controller card. Data on an ESDI drive could not be read by an ST506 controller. The industry eventually settled on IDE, and for a moment it seemed like the lesson had stuck. Standardize the interface. Let the hardware compete on specs. The Toshiba MK4401 NTD did not get the memo. 4 gigabytes, 0.85 inches across. Guinness World Record certified it in 2004 was the smallest hard drive ever made. It shipped inside the Nokia N91. Spinning magnetic platters inside a feature phone. Then flash memory got cheap, and the entire product line vanished. The drives sat in collections, unreadable because they speak a protocol that looks like MMC+, but isn't. Here's a question the hardware preservation community rarely asks directly. When a format dies without documentation, is the data actually gone? Will Wong spent years on this. He collected MK4001 MTDs. Working and broken. With the long-term goal of reading one. The connector looks like an 8-bit MMC bus. Reasonable assumption. Wrong assumption. The drive ignores ACMD41, CMD55, CMD8. The standard initialization commands. It doesn't behave like storage. It behaves like something waiting for a password it never published. So, Wang built a reader from scratch. USB 2240 chip signals broken out to 0.1-inch headers. A logic analyzer tap on every line, and an actual MMC Plus card soldered to the board as a reference. Side-by-side trace comparison between known good MMC Plus and the Toshiba. This is what debugging looks like when there is no documentation. You build two conversations in parallel and find the divergence. When that wasn't enough, he bought a Nokia N91 specifically to probe it, soldered wires below the spring contacts, reassembled the phone, powered it on, and watched what a live host actually transmitted to this drive in operation. What he found, the protocol deviates from MMC in deliberate specific ways. Toshiba designed this. They just never told anyone. The drive eventually yielded. File system intact. Files readable. Custom hardware, a sacrificed Nokia. A logic analyzer, and months of patience. All to read 4 gigabytes from a format that survived 3 years on the market. The original engineering that built this drive is remarkable. The archaeology required to read it 20 years later is something else entirely. It is the kind of work that keeps knowledge alive after the companies that made it stop caring. This has been your daily tech feed for Hacker News for March 20th, 2026. This podcast is entirely AI generated. Scripts by Cloud Opus 4.6. Voice by Quen3TTS. Not affiliated with Hacker News or Y Combinator. Now go ask the question nobody else thought to ask. We'll see you back here tomorrow.